Hi everyone. So happy New Year. Um, we're gonna do Intro to Fusion Part 2 today. It's a little bit of an odd, I guess, timing because the first Part 1 was done at the end of November. So maybe some of you were on that call, maybe you weren't, but we're gonna continue from that part using the same part. And if you were on the call, you can open up the one you had. If you weren't on the call in November, I have a sample file that you can just start from. But I'm just curious, who was on the last one in November? I think it was the end of November. If you could use your reactions, check mark, thumbs up, whatever. Looks like 4 people were. Okay, cool. So some new faces as well. So last time we went through making the bracket part of this, or most of it at least. So today we're going to assume that part is done. So I have an intermediate file so folks can start with that done, and then we'll add a second part being the pin, and we'll add a third part being this clevis, and then we'll add the screws, and then hopefully I'll have time to show you some additional areas of fusion to kind of foreshadow the rest of it. So I'm going to go through some basic stuff. It's going to be a little bit of review, but hopefully it'll be very quick. So the format of the workshop is going to be introduce topic, demonstration, and then hands-on. So I'm not going to ask you to do the hands-on portion while I'm talking. I'm going to demonstrate it and then pause and then let you try it. And that way you don't have to multitask, which is really difficult to do off here, especially if you're on one monitor. All right, so I'm going to skip this part here. I guess I'll just talk to this slide, which is that maybe, sorry. So Fusion is a integrated end-to-end product development platform. So the idea is that it is a complete solution for design and manufacture. It has a ton of features inside of it. You know, today we're only doing the design portion, but there's a complete manufacturing package, there's simulation, there's generative design, there's animation, there's rendering, there's so much technology built in. So this is really just the tip of the iceberg that we're doing today, but just know that the idea behind it was to create this integrated platform. So it's not just a CAD platform, it's a lot of different things. It's a CAM platform, it's an EE platform, but it wears multiple hats. And the other thing about Fusion to note is that it's a hybrid cloud and desktop platform. So you can typically you would run Fusion on your desktop, but all your files are stored in the cloud. Recently, we added the ability to run Fusion on a web browser as well via Chromebooks for a lot of the secondary students and middle school students who were given Chromebooks during COVID by districts, and they needed to run Fusion on that, so we developed that. So that's pretty recent, but typically, especially in the university side, we see most people running it on desktops and then using the cloud data management capabilities. Okay, so I'm going to, can we do one more poll here? We do one more poll, and can you put a thumbs up or a check mark if you have an Autodesk account with Fusion downloaded and an education license. 2, 3, 4, 5, 6. Okay, cool. So for those who don't, you can start the process now if you want to go get to go download Fusion and get an education license. You can start at I'll put in the chat It's autodesk.com/education. And you might may be a little bit of a lag, but you can start now and maybe catch up and get that done by the time we start the hands-on portion. Okay, so we talked about Fusion Team. We talked about cloud data storage. So Fusion Team is basically your hard drive where data is stored, and under that you create projects. Under that you create folders. So this is a pretty similar structure to basically anything you would manage on your computer, on a Dropbox, on a Google Drive. So don't get confused by the term Fusion Team if they ask you to create a Fusion Team or share your files in Fusion Team or anything. Just know Fusion Team is your hard drive. It's where your files are stored. And by default, it's a team of one. It's just you until you invite other people. Okay, let's keep going here. We talked about all this last time, so I'd say if you can watch the recording, you can get in more detail here. I don't want to repeat. Okay, so let's start in Fusion, where we left off. So I'm going to share my Fusion screen, and this is what we're going to make, and we can do some renders of it if we have time. Or more likely you can do that on your own time. So what I want you to do is open Fusion. So I'm going to tell you what to do first. Make sure Fusion's open. And then we're going to find a couple files. So under the samples area, so my files are up here. I scroll down, it says samples. We're going to go into workshops and events, education, and then design. And then under design, we're going to open two files. We're going to open the bracket modeled, so we can double click on that to open it. And then we're also going to open clevis modeled. So bracket modeled and clevis modeled. So once you have done that, can you put a thumbs up or check mark in the reactions? So open Fusion and then go into the samples area, workshops and events, education, design, and then open bracket modeled and clevis modeled. And yeah. Okay, one person's good.
Sorry,
any
quick
questions,
question.
feel free. What?
Yep, I don't seem to have that pane on the left.
Yep.
Where can I access that?
Hit the 9 dots in the top left.
Oh, okay. Yeah, I must have, yeah, I'm probably having a problem with my internet. It's not loading, but yep, thank you. I'll troubleshoot.
Okay, make sure you're online, and you can check that Fusion's online by hitting the clock in the upper right, and it'll say it's working online or not.
Thank you.
Yeah, for sure. And that's a good point. So the way you access your data panel is the 9 dots. And like I said, this is the hard drive. This is where your data is stored. So this is like, you're going to organize all your Fusion files kind of in a mini desktop, the way you would do it on a Dropbox or something. So you're going to organize it into projects and things like that. And note that anywhere that you sign into Fusion, your files will follow you. So if you sign in on a laptop and then on a different computer or maybe at school, anywhere you sign into Fusion on your account, your files will be there. All right, so one person was done. I'll wait a few minutes and feel free to ask any questions about how to get the files. There is no maximum. So the question is what is the maximum storage for Fusion Cloud? There is none. Yeah, it's pretty awesome. So for folks who aren't done with this step, Is it, are you just waiting for Fusion to load? Okay, someone says I need to update product. Can you use it without updating? Usually it'll let you oh, it doesn't let you open the file. Okay. Let's try this a different way. All right, I'm going to upload into the chat the files. Let's see if this works. Okay, there's one. Did that work? Can folks can folks open that? I just sent a file over the chat. It says I cannot see it here. Okay. Can anyone else see it, or is it not available? Andrew can see it. Okay, so if you can see it, okay, great. So I'm gonna get you the other one as well. 1 second. Okay. All right, there's the other one. So if you can't get it via the samples folder because it's updating, you can try the files I just sent over the chat. Okay, hopefully that covers everyone. But like I said, it's exactly the same ones as you would pull from the samples folder. So either way, you get it. So yeah, one more time, thumbs up if you're at this step. Okay, 1, 2. Okay, there still seems to be a bunch. Oh, and then the other thing is if you downloaded it from the chat, you have to save as, or you have to upload it. So then you would go and upload it into a project that you want. So you could just hit upload and then upload it into Fusion that way. And if you opened it from the samples folder, you can just save as to create a local copy in your Fusion team. Because right now it's, this is the one in the samples folder. Okay. If folks are having issues, can you, speak up about, tell them what's going on?
Yeah, I think I was able to find the samples folder when I click open. So I was able to find samples there. Can you please just provide the chain that I need to go through to get the part?
Yeah, so it's workshops and events, education, design.
And this one is
it's bracket and clevis, bracket modeled and clevis modeled.
Got it. Thank you.
Great. So you're all set?
Yes.
Okay, great. That's okay. So I think 4 people are good. Is there anyone else we're waiting for? Is there maybe folks can tell me what the issue is or what they're waiting on? That would be helpful. Okay, I'm going to assume that folks are good then. So folks are just waiting for it to upgrade the software. Okay, that makes sense. So when you get there, it doesn't prompt you. Deleting the app and re-downloading won't actually do anything because it's based on your account. So you can just try signing out and signing in. But if you need to upload in order to see the files, you can't really get around that. So you'll just have to update it. But it shouldn't take that long, a couple minutes usually. Okay, we're gonna keep going here because I want to get through this before the hour is up. All right. Yeah, so I want to get your name right. Is it Sohail?
Yes, you can say Sohail.
Sohail. So Sohail says after the update is done, everything's good. So I think that is the way to go. All right, so the first thing we're going to do when we have our bracket open is we're going to create a joint. So the way to kind of talk about joints in Fusion, I'm going to close the data panel here to get more space, is that joints assign position and motion to our components. So this is a bracket component inside of an assembly called bracket modeled. And right now, I can move it around. And that's more apparent if I turn on the origin. So this is the origin of the assembly. And I can move the part around in reference to the origin. So it used to be on the origin, now it's to the right, now it's to the left. And when you're modeling in mechanical assemblies, you don't want to be able to move your components around. So we want to assign an as-built joint to that. So actually, I realized I did not do the thing that I told you to do, which I have to save it as my own copy. So I'm saving it as, okay, now it's my own. So I'm going to do an as-built joint. So what an as-built joint is it assigns, it locks the position. It assigns a position and motion and then locks that position and motion. So in this case, I want to make it so I can't move this around anymore. So the position is locked. And I want to lock the position of the component, which is bracket, and I want to lock it relative to the top level assembly. So I'm going to do an as-built joint between bracket and bracket modeled. So under assemble, I'm going to select as-built joint. It's the third one. I'm going to select the component, and then I'm going to select the top level assembly in the browser. And it's going to have a default of rigid joint, and I can animate it. It's going to shake a little bit to show it's rigid. And now if I hit OK, I cannot drag it around anymore. So now it's locking the position. And the reason I did as-built joint versus joint is that as-built joint locks the positions of the components in the locations they are already in. So since this was already in the right location, I just did a joint as it was built. If it was in the wrong location, I would do a regular joint so I could move it into the correct position. But as-built joints is exactly what it sounds like. It joins it as it's built. So I'm going to pause now and let you all do that. So in your bracket, under assemble, as-built joint, select the bracket and the top level assembly and hit OK. And if you have any questions about that, or you want the steps again, let me know. And then thumbs up or like when you're done. Okay, two folks are done. 3, nice. Okay. All right. Any questions about this step?
Yeah, so
yeah.
Quick question. You said that with regards to as-built joint versus regular joint, as-built would like fix it in the position it is currently in, and then regular would allow us to move it before fixing it. Is that correct?
That's correct. Yeah, that's a great description.
Okay.
Yep.
Okay, thank you.
And we're going to do some joints later on. All right, so we're going to make a new component. So we're going to create new component. It's the top one. And make sure that when you can name it pin, and make sure that the parent is the bracket modeled. We want the parent to be the top level. Otherwise, it's going to be filed under bracket. It's going to become a subcomponent of bracket. We want it to be at the same level as bracket, which means it needs to have the same parent as bracket. So the parent is bracket modeled, which is the top level. So make sure that's highlighted here. Other than that, I didn't change anything. I just changed the name to pin. And I'm going to hit OK. So now I have a second component here called pin, and the bracket kind of becomes transparent because it's not active right now. And I can tell the pin is active because it has a target next to it. So now what we're going to do is create the pin. So we're going to create a sketch. And I'm going to create it on this mid plane here. So this right plane. And then I'm going to snap to it. So I'm going to pause there and let y'all do that, and thumbs up when you're good. So make a new component, make sure that the bracket modeled is the parent, and then create a new sketch on the right plane. And then thumbs up when you're done. Cool. Andrew's done. Okay, so Hill's done too. All right. Any questions about, oh, there's a question. Wait, how do you create a sketch on the right plane? Yep. So if you just go under create sketch, it'll ask you to select a plane. It'll automatically prompt you to select a plane. And then I just clicked on the plane I wanted. Okay. All right, I'm going to go back in and edit. Okay, so I'm going to start creating this pin. So this is part 2 workshop, so I'm going to show you a couple more tricks. So I want to build this pin in the right location. It makes it easier. It's a nice, it just means I don't have to move it. It means I get the dimensions right. I can link the features of the components to each other. So I want to be able to snap to the geometry. So what that means is that I have to bring geometry in from the bracket into my sketch. So I'm going to select both of these inside faces. So I clicked on one, hold down Shift or Control, clicked on the other. And I'm going to hit the P key on my keyboard. So P for project, or I could go under Create, Project, Include, Project, or just the letter P on the keyboard. And after I selected those, I hit OK. And what you'll see is that it's projecting the sketches, it's projecting that feature onto the sketch. So now I have things I can snap to. So from here, I'm going to create some lines. So I go under Line, Create Line. I'm going to start here, I'm going to go to the end. Then I'm going to go do another line here. I'm going to do another line that's aligned with the bottom here. Come back, do another line to the front. And now I'm going to create something kind of a head for the pin. So let's do it this way. There we go. So actually, I made a slight mistake. I actually don't need these lines on the bottom, so I'm going to delete them. Sorry about that. I only need half of it because I'm going to revolve it. So make lines across the top and then make an extra line here, come down halfway, and then come up and kind of make a profile of a bolt. And we're going to get this to stay in the middle by creating a constraint that allows it to be locked to the midpoint. So let's see, how do I want to do that? I think what I want to do is I want to make a line here that goes from the midpoint to the top. And then I want to put this on that line. Yeah. So actually, I'm just going to sketch that whole thing over again because I feel like that was a little bit unclear. So I'm going to first project that. Sorry, everyone. This one will be much clearer. And I'm going to start making some lines. So I'll start at this top left, come over here, and then I'm going to come out here, make one going down, make one going over into the midpoint of this into the midpoint of that purple line, which is the projected line. Then I'm going to start there and come back to the center. Come over, up, around, down. And I'm going to add a couple of dimensions here before I hand it off to let you try it. So I hit sketch dimension or create sketch dimension on the bottom. This is going to be 0.25. This is going to be 0.25. And then this is going to be 0.5. So I'm going to leave this here, and I want you all to recreate this sketch. So first project, and then create all those lines to make this pin. And I'll pause there, and thumbs up when you're good. And please post any questions.
Sorry, on my sketch, some of the lines are black and some are blue. Does blue mean they're wrong, or?
Blue just means they're under defined or under constrained. Which ones are blue?
Almost all of them except the first two.
So that probably means that they're not snapped to the vertices of the purple projected lines.
Mm-hmm. Okay.
So if it's blue, it means that the position is not constrained. Like if I make a line out in space, it's going to be blue because I can move the edges. It's not sure what length it is.
Mm-hmm.
Mm-hmm.
Okay, I'll fix it. Thank you.
Yeah, if you have more questions about how to fix it, please unmute and ask. But basically, if you look at my screen one more time, what I did was I projected the inner bores, and then I clicked on the vertice, and I made my lines between the vertice. And if you make your lines between set vertices, it's going to be fully defined because those vertices are fully defined.
Yeah, makes sense.
All right, one person put up their thumb or put a check mark. How do you change the dimension? So if you place a dimension, you can double click on it to change it.
Hi, I was wondering if could you please show how you constrain the very bottom line to the center of the circle, please?
Yeah, so what I did, I'll delete that line again. So it's actually 3 lines, and I found that was easiest. So I made a line between this and the center of the purple line, and I found when I hovered over it, it had an X with a triangle, and that X with the triangle denotes the midpoint. So I just clicked there, and then it was constrained to it, and then I did another line here, and then another line here. So I'll do that one more time here, and I'll do it without this vertical line. So if I make another line, I came down, and it doesn't really ask me to snap. So what I did to know where to stop this vertical line so it would snap, it would be at the same height as the midpoint, is I went and hovered over the purple line at a diagonal, and now it shows me the midpoint. And then I drag this, I move my mouse over, and now it gives me these dotted lines that kind of show where that reference point is. So as soon as you hover over something, it's going to now reference it. So then I was able to place it here and have that be the same exact height as the midpoint. Then I click on the midpoint, then I create this long line, and then I create the end here. Does that answer your question?
Yeah, that's perfect. Thank you very much. And I think I remember you doing something, drawing a line from the top of the circle to the middle, and then using the constraints function to specify the
Not in this one. The way I got the midpoint is just by clicking on it.
Okay.
So like when I drew this line from here to here, by clicking on that X with a triangle, it just made a midpoint constraint. Here you can notice this is able to move. It has it's not constrained, and that's because this line is not vertical. So there's a couple ways to do this, or it's not horizontal. So I could force it to be horizontal, and now it's fully constrained. But a more robust way to do it is to actually just force this line to be collinear with this line, meaning that they have to be, they have to be collinear. So that's this constraint, and I can click each line, and now it's collinear with each other.
That's really cool.
Yeah, so there's a lot of different ways to force it to do it. All right, so I think I'm gonna keep going. Hopefully folks are up to this. I saw there's I also don't want to get your name wrong. Is it Parin?
Yeah, no, yeah, it's put in, but I'm not able to change the dimension. Like everything is moving when I try to like reduce the dimension.
So if everything is moving, it means that it's not snapping to those points.
Okay.
So I would try it again, and when you make lines, like snap to these points.
Oh, okay.
And if those purple lines aren't showing up, it means that you haven't projected.
No, I think yeah, the purple lines are showing up, but then yeah, the snap part is I don't think I did that. Okay.
Yep, so that would do it. All right. So at this point, even if you don't have a fully defined sketch, I want to keep going so we get it in there. And we're going to do a revolve. So with revolve, we're going to select every part of this. So 5 for me, it could be slightly different for you. And then we select the axis by which we revolve. So we're going to select this bottom axis. And as you can see, that's going to make a pin. and then I hit OK. So that was the turning the sketch into a solid. We hadn't done a revolve yet, so there's the revolve. Yeah, and I'm going to do one more thing, and then I'll pause and wait a couple minutes. So I'm going to add a chamfer. So modified chamfer, and all a chamfer does is sort of creates, or it cuts an edge basically. So you'll see here, if I add I'm adding a chamfer on this edge of 0.006, or sorry, 0.06. And you can see it basically makes a bevel on that edge. I'm going to hit OK, and I'll pause there. So I revolved, and then I made a chamfer. And if anyone's still struggling on that sketch, I'm happy to help you out there. Oh yeah, and thumbs up when you're good on that step, or up to this step. Okay, so Hill and Andrew. And I would say if your sketch is not fully defined and it's still blue lines, as long as it is sort of in this area, it's worth it to just revolve it and keep moving forward, so you can learn all the different steps and not get stuck on the sketch.
Sorry, quick question. After we do the revolve, is the pin supposed to be freely moving?
It is. So, we haven't done a joint yet, right? So I can drag it. We have to do, the next thing we're going to do is a joint. You kind of, you're ahead of the game. Your line of thinking is correct.
Sounds good. Thank you.
So if you want to try it now and just play around, so do this is already in the right place, right? So as built joint, and you can create that. And this one we want to revolve. Okay. Corinne, how's it going?
I'm still working on it. Is it possible to show it again?
Absolutely.
The revolving part.
Would it be helpful for me to do it again one more time?
Yeah.
Okay, that's fine. So I'm gonna drag my cursor before I did it, so I can try it again. So the first thing I did was I selected these two interior faces, and then I projected them. So then it'll turn, I have these two purple lines. So now I go into the create line. I'm clicking on the vertice of the top left one, and notice there's nothing here when I click, and then when I'm on the line it has an X. So here it's a plus, line it's an X, and then in the vertice it's a square. So I'm clicking there, then I'm clicking again at the vertice on the top right. Now that's a black line because I've established where it starts and ends. Then I'm going to click again going over. Then I'm going to click again going down, and I want to stop this line in the middle at the midpoint. So to do that, I'm going to hover over the midpoint as an anchor, then pull it out and click down here so it stopped exactly at that midpoint. Now I'm going to still have the line tool. I come here, clicked on that midpoint, start the line tool again, click on the other midpoint, start the line tool again, come out, come up, come over, come down. And now I'm going to add dimensions. So I added 0.25, 0.25. And then this is 0.5.
Okay.
Is that helpful?
Yeah, thank you so much. Thank you.
Yeah, of course. Okay. So, I delete that. All right, so we're going to do an as-built join. So we're going to click the pin and click the bracket and make sure the motion is revolute. So now it can revolve. The last thing we have to do is snap to a axis of revolution. So we'll click, you can click this edge, you can click the cylinder, either one, any cylindrical face or edge. And now we hit OK, and it's a little bit hard to see, but it can revolve. All right. So the next step, and I'm going to let folks get caught up a little bit, but the next step, if you haven't already, is open that other clevis and save as. So you want to save your own copy if you got it from the samples folder, or if you uploaded it from the files I put in the chat, it's already in there, so you don't have to save as. But if you save as, make sure you, put it where you want to put it. And then once you have your own copy of it, you can navigate to it in the in your Fusion team. So open up those 9 dots, navigate to wherever you saved your local copy. So I saved mine in my workshops folder. And what I'm going to do is drag it into the current file, or right click on it and right click and hit insert into current design. And you don't have to move it, you can just put it there and hit OK.
Can you repeat the, sorry.
Yeah.
Can you repeat the joint portion? I'm having trouble after selecting both items. I'm not seeing options for the revolute, and I'm unable to proceed.
Okay, so assemble as built joint.
Mm-hmm.
I selected these 2 options, and then it says snap. So snap to, I selected the cylinder. You could also select any of an edge. And now it gives me options for where I want to rotate about. But what you probably saw was it just like this. But I have to change the type to revolute. What?
Mm-hmm. Yeah, I actually missed the snap. I didn't select anything for that.
Okay.
So
good.
Yeah, thank
Resolved. Great. All right.
Sorry, I was wondering, when we choose revolute, it's going to ask for an axis of rotation, right? Which, how do I get that?
Yeah, so you can select any face or any axis or any edge that's cylindrical. So I just selected this face.
Okay, perfect. Thank you so much.
All right. So the next thing is to navigate to the clevis wherever you saved it and right click and insert it into the current design. So I will wait for your thumbs up to keep going on that step. And mine is here after I inserted it. It's totally fine that it was inserted into the middle. Not a problem. And if you're stuck and you want to see something again, just speak up or put in the chat. Cool.
Can you show how you uploaded the clevis model again?
Yeah, which part are you at? Do you have it in Fusion?
Yeah, I saved it already.
So you saved it. So you open your data panel.
Mm-hmm.
And then you found where you saved it. You see it in a list. So navigate to where you saved it. What?
Okay.
And then when you found it, right click and say insert into current design.
Okay, sure.
Or you can just drag it. Sometimes it works to just drag it in. Okay. Okay. I think I'm going to keep going here. Anyone have any outstanding questions up to this point? Okay. So we're going to move this around a little bit. So this is not joined, right? The other two are joined. This is not joined. So as soon as I move it, it's going to have this position thing pop up in the top right of the toolbar. And what that's basically saying is, do you want to revert? So revert goes to the last position that was captured, which is where I inserted it. Or do I want to capture this new position? So if I capture this new position, all that does is put a marker on my timeline saying it was moved here. So if I capture it, all it means is now this is the last recorded position. And now if I move it again and I revert, it's going to revert back to that last recorded position, which is over here. It's not permanent. It's just like a temporary kind of movement marker. So I tend to not really use them very much, but just know that's what it means. And sometimes if I move it and then I will say, you know, do a joint, it's going to ask me, do I want to capture the position or revert it? So I usually just say continue, which is reverting it to its last position, which is going to be moving it down here before I do anything else. So yeah.
Sorry, on that, does revert push it back to the last position or to the last captured position?
The last captured position, which in this case was just where I inserted it.
Yeah.
Okay, so we're going to do our first joint. So as built joints, we just did a couple of those. That's for when components are already in the right positions. That's for just assigning their motion, assuming they're already correctly positioned. Joints are for assigning both position and motion. So that's when the components are not already in the right place, as this clevis pin is not. So joints work by matching point to point. So you're saying I want this point on object A to be coincident or be, you know, aligned with this point on object B. So what we're gonna do here is have one edge aligned with a different edge just to start. So I'm gonna select this edge on the clevis, and then I'm gonna select this edge, and now you'll see that those are now aligned together. And you know, you might say like, oh, I want it in the center. What we're going to do is actually create the joint to be not just a revolute, but a cylindrical joint. And the cylindrical joint allows rotation and sliding. So it doesn't matter really where it starts, because it's going to be able to move across that cylinder and rotate. So I hit OK, and now we can see it can move across the cylinder and rotate. So I'll let y'all try that, and I'll open up the joint again, and thumbs up when you're good. And I expect you to have some questions about joints, so feel free to ask.
Sorry, which faces did you choose for the joint?
I chose edges actually, so I'll do those again. So I chose, for the first one, this edge. It's like the outside most edge. I could do this one, I could do this one. Either way, it chooses the center point.
Got it.
And then for the second one, I chose this edge.
Oh, okay. Thank you.
Mm-hmm. All right. Is anyone finished here yet? Or up to this step? Three of you, awesome. Kyle, I saw you were working on it earlier. Are you still?
Yeah, I've had just a couple issues with my Fusion. My piece expired. My user, I just had to re-authenticate that and going through.
Oh, the verification process?
Yes, exactly.
Oh, okay. All right, cool. Let me know if you have issues with that too.
Will do. Thank you.
Okay. Great. And I don't think any other folks were actively participating. Okay, so let's keep going. I know, also I don't want to get your name wrong. Samyang, you were downloading or you were updating Fusion. Are you still going through that process or looking to get caught up? Okay, great. And are you following along still? Are you up to speed? Okay. Okay, that's fine. All right. So the next thing we're gonna do is put limits on this. So right now it can rotate all the way into the model, and then it can, slide off the thing. So we're going to add joint limits to make sure that it is constrained to reality. So the way we do that is I'm going to demo first. So I'll expand my joints folder in the browser, and I'm going to find my cylindrical joint here, and I'm going to right click on it and select edit joint limits. So the first one it's going to do is rotation. So I'm going to click minimum, and I'm going to look at it from the side view here because it's going to be easier for rotation. So minimum is going to be this left side arrow. Let me hide the other joints here. So rotations, the minimum is going to be this left side arrow. So what I'm going to do is drag this arrow out to the point where I want the minimum to be. So it looks like that's negative 15 degrees. And then for the maximum, I'm going to pull out the other arrow to the other side of 115 degrees. So now I see a visual of the limits of each side, and I am happy with that. So I'm going to hit OK. And now when I drag, it cannot go beyond those limits on the rotation side. Now the other thing I want to do, I'm going to go back in and edit joint limits again. And I'm going to go under motion, I'm going to go to slide. Now I'm going to look at it from this way. Oops. Okay, so I'm going to select minimum again, and you'll see this left side arrow pops up. And for minimum, I'm going to pull it out to negative 0.75, which I think is the exact edge. And then for maximum, I'm going to pull it back to 0. And then I hit OK. So now at this point, I'm going to revert position, and it's not going to rotate. It's going to be limited on the rotation, and it's going to be limited on the slide. So I can no longer slide it into the components. That should not be what's happening. 1 second. Okay, should be negative 0.5 and 0. Okay, I'm not sure why that didn't register, but here we go. So now it's limited on the slide as well. All right, I will pause and thumbs up when you're good there. Okay, no one has put their check mark yet. So are there any questions? Confusing things? Missteps? Okay, working on it. Sweet. Okay.
Hi, it doesn't, for the joints, I don't have a cylindrical one, but it's rotating in the same way as it was for you.
It's on the second tab. So in this joint, you see it has a motion tab, and you can select cylindrical. It's the 4th one.
Yeah, I think I did that, but then it's not showing up under the joint section. I'm not sure why.
It's not.
For me, it showed. Yeah, for me, it showed up under the pin, and then so I had to open the pin and then open the joint.
Oh, you're so right.
Okay, I see it. Okay.
I did something, yeah. I actually did something wrong here. So for me, pin was under, I had clevis as a subcomponent of pin. So what I just did was I dragged it into the top level so that it was on the right level here. My bad. Cool. Yeah, it's important to keep the timeline clean. So what I did there was when I inserted the clevis, I had the wrong thing activated. So I probably had the pin activated whenever I inserted the clevis, which meant that the clevis was stored under the pin. Versus what I really should have done is had the top level activated so that when I inserted the clevis was filed under the top level. Whatever is activated is where things will be stored. So sketches, components, features, everything. All right, did other folks have that issue too, where they couldn't find the joint? And also, if you don't need to find it in the browser, a lot of it's redundant. So you could also right click on the joint in the timeline at the bottom and also edit joint limits from the timeline. All right, I only have a couple more things, so we should be good in a couple minutes here. All right. Do folks need another minute? Or have any other questions?
I seem to have done something wrong. So I was able to apply the linear limits in terms of sliding, but with regards to the angle limits, I apply them and then it still rotates 360. And when I check, it seems like I'm rotating the clevis, but the limits are moving with it for some reason. Not sure what I did wrong. Maybe I should redo the joint.
I think you need to fix the pin first.
Yeah, is the pin?
So currently when I rotate the pin, the clevis moves with it.
Right. Okay. So what you want to do is, okay.
Oh, I think I know what I'm.
Yeah, you want to make one of them rigid. Let's see here. Yeah. So when I move, oh, you know what you did that I didn't do is that when I made my joint, my clevis is actually not joined to the pin.
Yeah, that's what I did wrong.
Yeah, my clevis was between here, which is the bracket, and so it doesn't rotate with the pin. But all you have to do is go right click on that pin and change that pin to a rigid joint. And now it'll be fine. The other way to do it is then you could edit the cylindrical joint and make, instead of it being a cylindrical joint, you could just make it a slider joint. That way the clevis won't have its own rotational. It would be tied to the rotational of the pin, and it's just a slider. So there's a couple ways to do it. Or you could redo the joint to have it joined to the bracket.
Yeah.
Either way.
Thank you.
Okay. I'm going to keep going here just for the sake of time. So the last thing I want to do is show you how to insert hardware. So under insert, there's insert McMaster car component. And I don't know if anyone has used McMaster car, but it's kind of a pricey distributor for hardware, and they have all sorts of stuff. They have stock, they have stuff for HVAC, they have transmission, hydraulics, flow, pressure, electrical components. And what we're going to use it for is not buying any of that stuff, but rather getting the CAD files off of McMaster. So under fasteners, we're going to just navigate through the screws and bolts to find some socket head cap screws that are 1/4 20. I know that's, y'all probably use metric, and I apologize. And 1/4 20, and we're gonna do 1/2 inch long. And so thread size 1/4 20, length 1/2 inch, socket head screws, and we're just gonna click on that first one. And I will post this this part number in the chat, so you could also just search for it at the top of the screen if you just want to navigate right to the part number. But we're going to click on that part number. We're going to hit product detail, and at the very top we can download a CAD file. So under type, we're going to do 3D STEP and then hit download. And as soon as we hit download, it comes right in to the file. Like, we don't need to navigate to our downloads folder or anything. It's comes right in, which is super nice. And then we just hit OK. And I do want to note that when I did insert McMaster car, I had my bracket modeled, my top assembly activated, because remember, whatever is activated is where that component's going to go. So to make sure that the component went under the top level, I needed this top level to be activated. So make sure it's activated, then do insert McMaster car and navigate to the part, download the step file, and it should come right in. And a few of you might be wondering why my stuff is all colored. And when I have a bunch of components, sometimes I find it easier to distinguish if they're colored. And it's really easy to turn that on. All you have to do is go under Inspect, Component Color Cycling Toggle, and you can turn the colors on and off so that they are automatically assigned. And you'll note that I have colors, the same colors also assigned in the browser and on the timeline. That's also a setting you can turn on, and that's in the bottom right corner. It's called Component Color Swatch. So if that's turned on, and then I turn on Component Color Cycling Toggle from the Inspect menu, that's how I get it to be colored. So thumbs up when you've inserted your screw.
Sorry, I was wondering if you could please show how do we get the step file again?
How do you get the step file?
Yeah.
It should just, are you in McMaster right now?
Yeah, I only see add to order and $11.38.
Yeah, hit product detail.
Gotcha. Thank you.
Yep. Good question. Yeah, if you were going to buy it, you would just like put in your quantity and buy it. But if you want the CAD file, you have to click on product detail to get the option to download it. Cool. So you can guess what our last step is, which is to do a joint. Similar to the clevis, we're going to do a joint between the screw and one of these bores. So I will, I'll wait another minute for you to get a little farther. Cool, Andrew's good.
Sorry, can you quickly show where the McMaster car section is?
Yeah, it's under Insert. Insert McMaster car component.
Oh, okay, okay. Thanks.
Yep. And you can just search that part number I put in the chat right from McMaster. It should bring you right to the part, and then you hit product detail to get into it. All right, so for the last step, I'm going to do a joint, and I'm going to select the cylinder, well, actually the edge of the bottom face of the screw head. And then for the second one, I'm going to select the edge of the top of the bore. And it's going to default to the last joint type I did. And it's also going to be flipped. So I'm going to hit the flip button. And then in my motion, I'm going to make sure it's revolute. So I just want it to revolve. And then I hit OK. And now I think we're going to stop there. If I wanted to add more screws, I could copy and paste this. So I could copy and paste it and then do more joints. I could also do a rectangular pattern of the component, and that would put it in the right place. So there's a lot of different ways to kind of duplicate that. All right. So I'm just curious, where are folks at here? Which step are you on? You can type in the chat or Say it out loud.
I inserted the screw and doing the joint now.
Okay, so you're pretty much caught up. Okay.
Yeah, I'm still inserting the screw.
Inserting the screw. Cool.
Mhm.
Kyle, are you verified?
I am now. So I was able to get my account up and organized again now.
Okay, great.
Well, thank you very much, Gabby, for
Yeah, you're welcome. I'm gonna
sharing
put
all of them. Great.
I'm gonna put this PDF in the chat.
Amazing.
There's probably going to be slight differences in the PDF to what I taught today, specifically around like, you know, which edges did you select for the joins and things like that. But there's really no wrong way to do it. CAD is very freeform. So if you wanted to review any of the steps, it should be there.
Great.
Give me 1 second here. I will find it.
And thank you very much, everybody, for attending and coming to the workshop today. I believe we have another one next week. And to remind you all that our Designathon will be happening on the first weekend of February, starting February 5th, I believe. So you can correct me if I'm wrong. 5th, 6th, and 7th of February.
Correct.
And everything can be found on our website. And the workshops will be posted on our YouTube channel at utdl.tech if you search that in the YouTube search bar.
Can you please go over inserting the screw once again?
Sure. So you go to Insert, McMaster Car Assembly, and then did you just search for the part number?
Yeah.
Okay. Then you see it pop up. So then you hit Product Detail.
Okay. Yeah.
Okay. Great. And then you're on the page with the product. You see at the top it says download. It has a download button.
No, I don't see it. 1 second.
Okay. I will do it here. Okay. So I'm gonna search for the part. I hit product detail, and now it says download right here.
Oh, okay.
So you make sure it's 3D STEP and then download.
Okay.
And it should bring it right into the part or into the model. All right, so that is in the chat. All right. Well, thanks everyone. For those who followed along, I think we went kind of fast, so I'm really impressed you finished it up. That's awesome.